Hi, in this video I'm going to go through part F on question 1 of the Math 2014 paper. So this question gives us two functions, s, which is x plus 1, and t, which is minus x. And we are told that s is applied s times, and t is applied t times. And we've applied those functions just in some order. And eventually we end up with f of x is equal to 8 minus x. And we want to know which of these facts can we deduce. Okay, well, this first one certainly would work. I mean, if we applied t and then we did the function s 8 times, then we'd be adding 8 on to, well, what would be minus x after we've applied t. But then there are other ways of doing this too. We could have applied t 3 times first. We'd still end up with minus x, and then when we add 8 on, we still get this function at the end. So we can't deduce a. Okay, so what about this next fact? Can t be even? Well, every time we apply t, we're going to change the sign of x. And we see that we've ended up with a negative x, and so we must have applied t an odd number of times for this to end up being a negative. So we know that we cannot have t being even, and well, also if t isn't even, it's not going to be a power of 2. So we're only left with c and d. So now we just need to know if we can deduce that s is even or not. If we can, then we're going to get that we can deduce c, and if we can't, then we have that we can't deduce any of the above. Well, it might be tempting immediately to say that yes, s must be even because we've got an 8, so we must have applied s 8 times to get 8 added on. But we can actually end up taking off as well. For example, if I applied t s t to x, so when I apply t to x, I'm going to get that it's minus x, and then when I apply s, I'm going to get minus x plus 1, so it's 1 minus x, and then when I apply t again, I'm going to be taking the negative of the whole thing, so that's equal to x minus 1. So we could end up taking off as well as adding on, but if you look here, we've only applied s once, and if we're going to end up with an even constant added on, then if we added on an odd number, we must also have taken off an odd number of times to end up with an even number. And each time we add on, we apply s once, and each time we take off, we apply s once. So if we added on an even number of times, we must also have taken off an even number of times, i.e. if we applied s an even number of times, we must have also applied this an even number of times. So that's another even number of s's, because we end up with an even number. If we added on an odd number of times and applied s an odd number of times, we must apply this an odd number of times too, to end up with this even number. So that's another odd number of applications of s. So odd plus odd makes even, and even plus even makes even. Therefore, we must have applied s an even number of times in total. And so we know that our answer is C.